Hi, welcome to this tutorial about probability trees. What are probability trees? There are diagrams that shows different combination of two or more events. In my previous session, I showed sample space, which showed different combinations of two events. When you have more than two events, you need to use probability trees. Well, I'm going to start with one simple example, and then I will do a typical probability question. Right, so let's say I'm flipping a coin twice, or I have two coins, and I want to show all the possible combinations and then use that to work out probabilities. Well, I have two events. If I flip the first time, so flip one, and then I'm going to have a second event, which is the second flip, so flip two. So when I flip the first time a coin, what could I get? Well, it could land on the head or the tail. And if I got the head the first time, what could I get the second time? Well, I could get the head or tail. Similarly, if I got a tail the first time, the second time, I could get the head or tail. So now what do we need to do after this? Well, we need to show all the different combinations. And how do we do that? Well, we follow branches across this way. So we go across. Now, because I'm doing probability, I need to write down a P. So probability of getting head and head is over here. So head and head. And over here is going to be probability of getting head and tail. So head and tail, and here tail or head, so I go across that way. So probability of getting tail and head, and the last one is going across this way, so it's tail, probability of getting a tail and tail. Have I finished? No. I can see I've got these combinations. I can get head and head, head tail, tail head, tail tail. Well, you need to include probabilities of each outcome. So what's the probability of getting the head? Well, if it is a fair coin, then probability of getting the head is half. So you need to write them on top of the branches. Again, it's the same coin, so I still have the same chance of half of getting the head or tail. And similarly here, my probability is half, and I'm going to put them up here. So how do we calculate then these probabilities? Well, similarly, we are going across the branches, but we need to multiply. So probability of getting head and head is half times half. So half times half, which is a quarter. Again, head, tail, probability on branches, half times half, which is a quarter. And the probability of getting tail and head, same, half and half here, so half times half, which is a quarter. Again, tail and tail, probabilities are half times half, so half times half, which is a quarter. Okay, so now you've done all the combination and you've worked out the probabilities on each one of these outcomes that you could get on two flips. What else do you need to know? Well, each branch must add to 1. So this branch is one branch that needs to add to 1. 1 half plus half is 1. Half plus half is 1. Half plus half is 1. Also, probabilities of all events, all your outcome must add to 1. So a quarter, quarter, a quarter, and a quarter is 1. 4 quarters is 1. It must not be less or more. So total probabilities must add up to 1. Last thing I want to just give you a note of is these probabilities at the end, just leave them as they are. Don't try to simplify them, because if you need to add any of the probabilities, it is easy to add when the denominators are the same. Then you can simplify your final answer. So let's say from all my combinations here, and I want to know what's the probability of getting a head and tail. Doesn't matter in which order, I just want to be able to get head and tail. So it is 2. Okay, so as you go down, you add probabilities. That way we multiply, this way we go down. So I've got a quarter and a quarter. So probability of getting head and tail is going to be a quarter plus quarter, which is a half. Okay, so that's that question. Now, I've got this question here that says with replacement. So let's just understand that word. What does it mean, replacement? Well, it just means you are going to get something maybe from a bag and then you're going to put it back in the bag. So at any time you have the same number of whatever's in there. In this case, we have beads. We have 2 blue beads and then 5 red beads in a bag. You're going to take one out, make a note of it, and then put it back in the bag. So you will always have 7. Every time you try and get a bead from the bag, you have 7 beads. Okay, so let's show all our outcomes to start with, and then work out probability of getting a red bead and a red bead. Okay, so let's start. I pick 1, so I pick, that's an event, 1, and then pick 2, that's a second event. So first time I pick a bead, what could I get? I could get a red and a blue, and I could get a red again, or I could get a blue, or red, or blue. Sorry about my pen. So what's the probability of getting a red bead? Well, there are 5 red, 7 in total, so it's 5 out of 7. Again, second time, because I put the bead back in the bag, I still have the same chance, which is 5 out of 7. Now, what's the probability of getting a blue? Well, it's 2 out of 7. And again, what's the probability of getting a blue here? If I got the red the first time, probability of getting blue is 2 out of 7. And my chance for red again is still the same, so I write them on the branches, 5 out of 7. And same thing for blue, hasn't changed, so it's 2 out of 7. And the question is asking you to find probability of getting a red and a red bead, which is this one here, because red and the red. So what's the probability there? Well, it's 5 out of 7. And what do we do with probabilities? When we go across, we multiply. So 5 over 7 times 5 over 7, which is going to give you 25 over 49. 5 times 5, 25, 7 times 7 is 49. So that's your answer for this question. But what else do we need to do? Well, you can go and practice from your Fundamental of Basic Mathematics book if you're doing Nectar, page 102, exercise 4.4. Otherwise, if you're doing GCSE or IGCSE, you could use your own book or go to Math Genie, you know where it is, and just practice some questions from there. In my next video, I'll be showing how to do probability trees with no replacement. Okay, thank you for watching.